Hello, I'm Steve Anderson here at Merrill Manufacturing Company. Okay, today in this session we're going to talk about check valves. Check valves are basically a valve that opens and closes to control the flows, to keep the flow flowing in one direction. They close so it doesn't have back siphonage or backflow against a pump or some other application of some other appliance or something. It's to control the flow. And in most instances they can be installed both vertically and horizontally. The only thing is if you get say 1.25 inches or larger valve, then I would very strongly recommend that you go to a variable flow valve. And the variable flow valve has ribs on the inside, on the intake side, that helps guide the poppet that opens and closes and keeps it, if you installed it in a horizontal rather than vertical position, stored it horizontally, the ribs will keep the insides moving back and forth and not get crooked and stick and operate the way it's supposed to. If you get a bigger size valve that doesn't have the ribs on the inside, which is most all traditional valves do not have a rib on the inside, and you get bigger diameters, you have a bigger space and more of an opening for the stem and the inside of the valve, that if you had any kind of debris or anything flow through, the weight of the poppet could get off center and could get stuck and not close correctly. So most instances that doesn't happen, but it could. So the idea is if you're doing it in a horizontal position, it's much more preferable to stay with smaller size valves. But then again, the question is, what size valve should I use? You use the size of valve for whatever size the pipe is. So it's not like you change the valve just because you want to use a certain size valve. It doesn't do you any good. You really need to keep the size of the valve to match the size of the pipe that's being connected to. So as you can see, I don't know if how well you can see from the photo, but there's a stem, stainless steel stem, stainless steel spring, and the spring is such that it's made such that the inside poppet cannot spin. If you get a rotary motion to the flow of the water, it could take the inside poppet and make it spin on the inside and wear the poppet out, so the valve could fail. These are made such that that's impossible to do. It holds the poppet where it's supposed to. It opens up, let the water flow through, and if the water stops, and if there's some reason why the water would flow back, then this closes and stops the backflow, and which is the whole purpose of the check valve. And this is actually a no-lead brass. It's also available in a no-lead bronze. A no-lead bronze has a higher copper content and it's stronger. Also, that's very much recommended for buried applications. If you're going to be using it in a corrosive environment and going to be burying underground, you definitely want to go to a bronze or stainless steel, not the standard brass, and or standard no-lead brass. The other type of valve, which you obviously see, is actually a 2-inch size that I have here rather than the smaller 1-inch size. The 2-inch size, you realize how much bigger that is pipe size, but also you realize that this is a stainless steel one. And the big advantage of this one is why I wanted to use this one is just so you can get a better feel for what the differences is of the valve, and you can see that better on the cutaway model, that this is actually a variable flow model. A variable flow model on this particular model of check valve actually has a poppet inside of a poppet. So when you have a low flow demands, only the center poppet will open and the water will flow. That greatly reduces the amount of friction loss through the valve, makes the valve work much more efficiently. And also then if you have a higher demand, then you can open up the bigger poppet and you'll get the full flow through it, and actually because of that you actually still greatly decrease the pressure loss through the valve and greatly increase the amount of water that you can actually flow through the valve by minimizing the pressure loss going through the valves in the first place. And because of that, you realize you can see the ribs on the inside, so it is designed for, even in the smaller size, to be installed in horizontal positions rather than just vertical. And as far as temperature ranges, temperature range, it should be below 190 degrees, only because the special seals, the O-ring seals that are inside the poppets are of a rubber material that won't withstand temperatures above 190 degrees. And the other thing, as far as well depth, these are easily used 200, 300, whatever, 400, and we even have some really heavy duty valves that can be used at, I think they've had some instances they put them 1,000 feet down. So as far as realizing the amount of weight and the amount of strength that's required, there's a lot of different valves and different series that we have available, and they're all for various different purposes. But really the best valve, for the best flow efficiency that helps out your system and it greatly decreases the friction loss through the valve, is the variable flow valve with a double poppet. And those are available right now just in stainless steel, but they will be available in bronze and ductile iron later on this year. That covers most of the things in regards to check valves, and if there's any other specific questions, make sure that you ask any representative from Merrill or send us an email or whatever means you'd like to communicate. Thank you.